Okay, let's start. Sorry for the delay because I did not have power until right now. We will try to cover as much as possible, right? Did you take a look at the tutorial which I asked you to take? Okay, let's start. So hope all of you has gone through the material in the Learn OUSL as well as the things in your textbook, right? So what's the subject that we are going to study is engineering mechanics. So this will be the very basic course because engineering mechanics is one of the main subjects in mechanical engineering, right? There are a lot of practical applications which are based on the engineering mechanics, right? But the things that we are going to cover today, you may be mostly familiar with these things in your advanced level maths, right? These are not very difficult parts. They are pretty much similar to what you already know. So I hope that you have gone through in your textbook. So the first things that we are going to see is the motion of a particle in one dimension, then in plane, and then in three-dimensional space, as well as then we will go in later sections to the motion of a solid body, right? Before going to study these things, let me ask you a simple question. Is that what is the definition of a particle? What do we call something a particle? And I would really like if you can speak.
Hello?
Yes, what is the answer?
It is mass which is concentrated at a single point. Hello?
Yes, I can hear. You can speak up.
It is a mass which is concentrated at a single point.
So what's that mean? If it is a mass which is concentrated at a single point, that means it does not have any dimensions, right?
Yes.
So there is no length, width, or a height if you are talking about a particle. And the next thing is, remember, even though it does not have any size or geometrical shape or a size, it is just a point, but there is a weight or a mass, right? That's the definition of particle in engineering mechanics. And when it comes to the next one, which is a solid body, how do you define a solid body? In the same way,
It has a length, breadth, and height.
if you are talking about solid body, is that enough? If it is, what else it should fulfill to consider something as a solid body in engineering mechanics?
Mass.
Yeah, it does have a size and a mass because particle also have had those things. But when it comes to solid body, there is another thing that this really has to fulfill. What is that?
Particles are closely packed.
Particles are
Closely packed.
not the exact answer. What if to consider something a solid or a hard body? Remember that particles are not going to deform under the applied forces. Got the point? That means it should not change its shape due to the external forces. If you take a very hard thing like a piece of iron, it is almost fulfill this requirement. But if you take a soft material like piece of clay, what will happen when there is an external force?
It will get deformed.
It will get deformed. So those things, it is not very practical to consider as a hard object. And the next thing is that sometimes, even though it get deformed under the external force, we consider it as a hard object, right? When things like a piece of clay, right, you throw it away for a very long distance, right? When the throwing happens, it may deform, but the thing that we are most consider is the how it travels through the air, not what happens to the shape of the object, right? If it is kept intact, you can think for our purpose, it is a hard object, right? It depends on what is the requirement that you are going to not the requirement, the application or what you need from your calculation, right? Sometimes something which is deformed, but it really not going to affect what we need to get from our analysis. Then it's okay to consider that also as a solid or a hard object. And the next thing is there are some things which will deform continuously under an external force. What are those? Things which are going to deform continuously. They are not going to stop.
Fluid.
Huh?
Fluid.
I didn't hear you correctly.
Fluids.
Fluids, yes. Fluids are going to deform continuously under the external force. So in engineering mechanics, we are not going to deal with fluids, right? There's a separate branch of mechanics. What is that? Which is going to
Fluid
only
mechanics.
analysis the things which will continuously deform, which is the fluid mechanics. And there's another part which will also deal with change in volume. What is that?
Thermodynamics.
Huh? Not thermodynamics. Thermodynamics is slightly different. What is the part which is going to deal with deformation as well as motion? It is the aerodynamics or gas dynamics, right? So those two are separate parts, but actually, since all of these things really talk about the motion of a particle, whether it is internal or external, we can combine all these things and comes everything into a single thing called as continuum mechanics, right? Under that, you can deal with either solid or a liquid or a gas. But the thing is, if you go for that definition, things will be very, very difficult. The equations are very difficult. You get large number of constituent relationships, right? Then you need to simplify them according to your situation. It is not worth when you can do it very easily with the three separate cases, right? But in sometimes What is the point that we should consider? No idea? You did apply these equations. The simplest equation is Newton's second law in advanced levels, right? In there, what is the point that you took to shrink a 3D object to a point?
Center of mass.
Yeah? Typically, it is the center of mass. And what is the reason to take center of mass to represent our whole object? Right? If you are going to select one particular point, there should be a reason. Otherwise, any point will be okay. What would happen if you select another point? Not the center of mass, some other point. There are two things, right? Number one is that everything on earth is going to have always under the force of gravity, right? That force will give a rise to the gravitational acceleration, right? Anything on earth is going to have this force and the acceleration acting on them. So those two forces are going to be applied at the center of mass. That is one reason. And the other one is when you apply the Newton's second law for a particle in 1D, we always need to have the mass coming into that equation, right? F equals m into acceleration. In here, we are going to consider that the acceleration is going to act at the center of mass, right? Otherwise, what will happen is that if you take another point, you have the gravitational acceleration at one point, and we are going to consider our acceleration acting at another point, which is possible to do, but things will get very, very complicated. And it may be not possible to consider things as a particle, right? Because two different forces acting at two different points, right? So to be very simple, we always shrink and solid object into a particle at the point of center of gravity or center of mass, right? So if you consider a particle representing a solid object, what it really means is that we are considering a particle which has the same mass as the solid object, but no dimensions, and the particle will be located at the center of mass of that solid object. Got the point? Any questions? No questions? And let me ask another question. What are the advantages of shrinking down a solid object to a particle? මොකක්ද advantage? In 1D it is obvious, but when it comes 3D, is there any advantage?
We can ignore its space,
Huh? It's
the space of its acquiring.
if we are not confined in space, that is not really a problem, right? Typically we are, when it comes to the motion, we consider it as free space, like aircraft moving in atmosphere, right? There is lot of space and it really is not a problem. Or a fly moving through a room, or a cricket ball moving in air, right? Space is not really a problem, whether it is solid object with dimensions or it is a particle. Is there anything else you can think of? මොකුත්ම කල්පනා වෙන්නේ නැද්ද? particle එකයි solid object එකකුයි ගත්තහම 3D space වල move වෙද්දී
We can ignore the forces like air drag and other things.
okay, if there is air drag, you can ignore it, but that's not the real advantage, since you will later learn that the things that we are going to consider, the air drag and those things, do not play a real part. Now, if it is a solid object with dimensions, right, while it is moving, what it can do at the same time? If it is a particle, whether it starts from here and then it's going to move in a path like this and come to a point like this, right? So this is 3D motion, and particle will start from here and comes down to here. Now, if you take something like a cube, what will happen?
The coordinate will change.
Cube is there, not the coordinates. What will happen? The cube can come to a point like this, but at the same time, it can do what? Change its orientation. Got the point? It can rotate while it translates. That problem is not there if it is a point, right? Even without translating, a solid object can rotate on its own. So when you shrink a solid object down to a point, automatically we are free from the 3 rotations. right? Any questions? That's why always prefer to do things as particles. Do you need any clarifications? Why we should always go for a particle? Okay. Do you understand or you are not able to understand anything?
Understand.
Okay. So remember that the particle definition is very nice because you will free from the three rotations of the object, right? A particle cannot rotate on its own, right? So now let's do some simple or very basic definitions. What is the displacement? You should, I think you know these things. Displacement means what? You don't know. Displacement. Then velocity, and last one is acceleration. What is displacement? Is it a scalar or does it
It's a
have
vector.
a
It is a vector.
vector? Then what's the difference between length and the displacement?
Length has
Or
only
distance?
a magnitude,
Okay.
but displacement has a direction as well as a magnitude.
Okay. Then velocity. What is velocity?
It is the rate of change of displacement.
Rate of change of displacement. Okay. And the acceleration?
Rate of change of velocity.
Velocity. So typically, displacement, can you see what I am writing?
Yes.
Not very clear maybe. We denote it by letter S in 1D, and then velocity, which is V, is the time derivative of displacement, and the acceleration, typical letter A, which is the time derivative of velocity. And when you get the definition of velocity, you see that this is the second derivative with respect to time of the displacement, right? This is in the one dimension case. To simplify things and to move with 2D and 3D systems, since these are vectors, right? How are we going to write them in 3D space, right? What are the additional things that we need to represent displacement, velocity, and acceleration? We need the coordinate system, right? there are two different types of coordinate systems. One is the Cartesian system. And since we are going to deal with vectors, we need 3 unit vectors along each principal direction, I, J, and K, right? And the other one is you can also use polar coordinates. In polar coordinates, we have a fixed point, right? And then a vector. Let's say this is the origin. From the origin to the point that we are going to consider where our particle is at. Let's say the particle is A. So we have one vector along this direction, another one perpendicular to this. If you need the third one, it will be perpendicular to both of these things, right? That's also possible. So remember that if you're going for this representation, you can see that the vectors or the unit vectors, typically this is called as ER, E theta, and this one as EZ or any other one depending on your requirement, right? In this way, and when the particle moves to another point, unlike this case, what will happen? If the particle comes here after some time, your unit vectors also going to travel with that particle, right? So this one is a fixed system. This one is going to, the unit vectors going to change their orientation with the motion of the particle, right? Any questions? Fine.
So polar one is not clear.
Polar means this is not the spherical polar coordinates, right? What you do is you have an origin point, same like here. This is a fixed point. And then from that fixed point, suppose your particle is at point A, right? From O to A, you can define a vector, right? The position vector. Then, using that position vector, you can define a unit vector in the same direction. So ER is in the same direction as the position vector of A. So the position vector is OA, and this ER is really OA divided by mod of OA. Right? Then you can define the other unit vector which is exactly perpendicular to this ER unit vector, which will be E theta. How is it?
Yes.
if you need the third one, typically we apply this to planar motion. So the third one is not really necessary. But if you need it, then you have to define it perpendicular to both ER and E theta, which will be EZ. Okay, now let's suppose particle is at this point in Cartesian coordinates. So the position of this point will be X, Y, and Z, right? If the position is given as X, Y, Z, what is the position vector? OA. And what this OA will represent is the displacement of the point. So how are we going to write it? හරි නේද? OA එකෙන් පෙන්නන්නේ point එකේ displacement එක origin වල ඉඳලා. Now my question is, how are we going to write this as a vector? Cartesian coordinates are given as X, Y, and Z. 3 unit vectors are there, I, J, K. So the displacement or the vector OA is really X,
xi plus
I plus
yj
YJ
plus
plus Z.
zk k.
Okay. Then what is the velocity? V is D
x
OA, not dx. The whole displacement vector you have to differentiate, right? Which is d xi plus yj plus zk, and you need to take the time derivative. Okay, do this very quickly. We can use what to expand this? D xi over dt. We can separate the addition mark. D yj over dt. D zk over dt, right? After that, what to do? You have x and unit vector I. So you need to apply what rule? The multiplication, remember? So this will be dx over dt into I plus x into di over dt, right? In the same way, you have to expand these things. And what is this one? Di over dt. Or we can only ignore this part and just write this one. මොකද හිතන්නේ? dx over dt into unit vector I plus x into time derivative of unit vector I. There are two questions. One is, do we need this part? If we do, what is the value of this one?
We need that part.
Huh?
We need that part.
Okay. Then what is the value?
0.
Why? Why it is 0? These are unit vectors, so their size does not change. Then what they can change with respect to time? Unit vectors can change their orientation, right? But if you go for Cartesian coordinates with unit vectors I, j, k, the special thing is that these unit vectors are fixed with the Cartesian directions. So because of that, this will becomes 0. And you will see that in the next part, that is not going to happen, right? Under polar coordinates. Right? In the same way, we can get, so I am not going to write that for this one, dy over dt into j plus the z over dt into k, and to write things little bit simply, we use dot notations to represent the time derivative of any quantity, right? X dot into I plus Y dot into J plus Z dot into K. Now find the acceleration of this particle, which will be d vector v over dt. Finished? So the second derivative, the same way we can represent as 2 dots, x double dot into I. I am not going to do the expansion. You can do it. Y double dot into J, Z double dot into K. can you have the access to this first tutorial? All of you? Were you able to access that one? Try to do the first question. The car moves in a straight line. For a short time, its velocity is given by v equals half 3t squared plus 2t. T is in seconds. Determine its position and acceleration. This should be very simple one because it is 1D and you should be very familiar with this type of questions, right? So the car starts from origin. T equals 0. S is also 0. You can see my screen, right? V is half 3t squared plus 2t, right? So what is the acceleration? It will be dv over dt, right? And what is the position?
By integrating,
Huh?
we can integrate
We know that
velocity.
v is ds over dt. From this we can get ds is actually what? V dt. So you can take the integration on both sides. When you do that, you will need the initial conditions, but they are given. For that you have very simple questions. Now let's move to the next part that we are going to consider, which is the case with the polar coordinates, right? Before going to the acceleration and velocities of the particle, first we need the derivatives of the unit vectors, right? So let's try to solve that part first. As I told you, we apply this one basically for mainly for the planar motion. So I am going to only consider 2D system. The Cartesian coordinates are x and y. This is the origin, right? On this system, we have a unit vector I in x direction and j in y direction, right? Now, on the same origin, I am going to define a unit vector along this line, which will be ER, and another one which will be perpendicular to this. These are unit vectors E theta. For ER and E theta, we are not going to use the underline mark, but to represent them as unit vectors, you put this hat mark. Now, what is the relationship between these unit vectors ij and ER and E theta? And the angle between x-axis and this ER vector will be theta. Right? So what we can do here, I am going to resolve or take the components of ER unit vector along x direction and y direction. So how much is this part? This angle is theta, right? The length is 1, so this will be cos theta. And this part is how much? It will be sin theta, right? So if you use this one, we can write this ER unit vector using I and j. So this is really cos theta I plus sin theta j. In the same way, can you define E theta vector using theta I and j?
Sin theta I plus cos theta j.
How much?
Sin theta I
Sin theta I, okay.
plus cos theta j.
Sin theta I, is it plus or minus?
Plus.
Sure?
Mm. Yes. Yes.
What is the direction of the sin theta component? Is this one, right? So you can see that this is pointing in the opposite direction to I, right? So it really is minus sine theta I plus cos theta j. Now what we need is to do our velocity and acceleration, we need d e r hat over dt. Can you get this one? So differentiate this part, d over dt cos theta I plus sine theta j. What will you get? Derivative of cos theta is what? Minus
Sin theta.
sine theta. And derivative of sine theta?
Cos theta.
Cos theta. And what is this one? Minus sine theta I plus cos theta j.
E theta.
Is e theta.
E theta.
This is really e theta. Right? So derivative of e r hat over dt is e theta. The same way, find d e theta hat over dt. Right? As I told you, not all unit vectors are going to be zero when they are differentiated with respect to time. So we are going to follow the same procedure. This will be d over dt minus sine theta I plus cos theta j. When you do the differentiation, we have minus cos theta I minus sine theta j. And what is
So
this?
how about the theta? So excuse me,
Yes,
that why we not differentiate that angle theta?
sine theta differentiation is the theta.
Okay, sir. Okay.
Got it?
Okay, sir. Okay, sir.
It is the angle. If it is not changing, we cannot differentiate. It will become zero.
Okay, sir. Okay, sir. Okay, sir. Got it, sir.
Right. What is this one? Okay, you ask about this derivative of theta, right? Okay, it should be there, yes.
Yes, sir.
Yes.
Because we are differentiating
Yeah, sure.
with time, no, sir.
Yeah, so you are correct. Theta dot, and the same thing here, it is theta dot. Good. There is a theta dot term. So this one is minus of E R. Right. So this is really minus theta dot E R hat. Right? So we have the time derivatives of the unit vectors. Is theta dot E theta and the other one D theta minus theta dot E R. Remember there is theta dot. Yes, you have to differentiate theta with time. Okay. Now let's go to our particle. So this is the origin, right? And the particle is at this point, point A, right? The distance from O to A is R. Okay. Now what is the position vector of point or the particle A? How much is this? And remember, we are going to define vector along position vector ER, unit vector, and one perpendicular to it, which is E theta. How to write this OA? And this is the advantage of using this polar or curvilinear coordinates, right? The position vector of A is only R, E, R hat. Right? The magnitude is R, direction is ER. Now find the velocity. V is what? D OA dt. That means d over dt r er hat. Can you try this one? We have everything. You just need to do the differentiation. So what is going to happen? dr over dt into er hat plus r d er over dt. So you will get r dot er plus r theta dot e theta. So this is the velocity. Now let me ask a question. If this r dot is 0, what is this motion? R dot 0 means you have a constant r. That means motion on a circle. Is our equation correct? Because you are familiar with circular motion. So r is constant, this is 0. You are only going to left with this part. Is it okay with your knowledge? හරිද මේ වේගය ඇවිල්ලා තියෙන එක? R dot, what is that? In circular motion?
Omega.
Omega is theta dot. This is the මොකක්ද මේ? වේගය. Speed of the particle around the circle. මතකද? R omega. Same thing is here. Only thing is that theta dot is represented by omega. Okay. Now the next one. We need to find the acceleration. A is nothing else but dv over dt. So you have d over dt r dot er plus r theta dot e theta hat. Remember that in this case, r is changing with respect to time, theta dot is changing with respect to time, as well as unit vector e theta is changing with respect to time. So you need to get the differentiation of all three of them.